All right, let's try to finish up the homework here. Look at question 8. Another survey of 400 people, but that might not be the total. Round your answer to 4 decimal places. So here it's number of minutes that people talk on their cell phones each month. If a person is selected at random, find the probability that the person was a woman. If it is known that the person talked between 600 and 799 minutes. And so that's this category right here. We know that it comes from this, so this is our total. So it will tell you on problem 7 and 8 which category to choose from, and you find that total. Here, it's just 227 plus 13 for a total of 240. And so the probability that it was a woman, and out of men and women here, women make up 227 out of the 240. This question seems vaguely problematic, but the answer to 4 decimal places is 0.9458. You could just put that in the calculator. And now, question 9 is a fun one. So the probability of getting an ace, a king, and a queen in that order. And so, we have 3 fractions here that we're multiplying. And we are not replacing these cards. And we're looking for the answer to 5 decimal places. So, you might be wondering what this looks like. It kind of looks weird in the calculator, so we'll talk about that. So the probability of getting an ace, well, there are 4 of them out of 52. The probability of getting a king, there are 4 of them, but we're not replacing the cards as we go, so it's out of 51. And then the probability that we draw a queen, there are 4 of them, and the deck now has 50 cards. So we're not replacing, so the denominator decreases by 1 each time. And so if you put these in the calculator, we'll take a look at what we get. So 4 out of 52 times 4 out of 51 times 4 out of 50. I put all my fractions in parentheses, and I just put the parentheses next to each other so they multiply. And we get this e to a negative 4 at the end. And so I write out the decimal that I have, 4.8265. And then e to the negative 4 means that we move the decimal to the left 4 places. And so there's 1, 2, 3, 4. And so the first time we moved the decimal, it just moved to the left of the 4, and then we moved an additional 3 times. So in those additional 3 times, or like the 3 divots you create, you put zeros. And so we have to convert something like this to 5 decimal places. And there are cases where you want very specific numbers, so that's why it doesn't just say 0.0048. I missed a 0. It gives you the very specific numbers in between. But for our purposes, we want to round this to 5 decimal places. So I write it out, and I move the decimal 4 times, creating 3 zeros. So that's our answer for number 9. Number 10. A survey of 230 college students shows the average number of text messages sent per month. Find the probability that a student sent between 1,000 and 1,999 texts, given that it was a woman. And so this is where we find our total from the category that is given to us, which is women. And so I added these up, and I got 115. And so find the probability that the student sent this many texts. That's those numbers right there. Given that it was a woman, so that's 14. So 14 out of 115. Again, that's like the given total. It's given that it's a woman, so we find that total. That's 115. The probability that it was a woman sending that many texts is 14 out of 115. Number 11. We have data showing numbers in thousands of licensed drivers in the United States. Age 19 and under, age 20, age 21, and then male and female. So choose one driver at random. Find the probability that the driver is female and 19 and under. And so I found this total. I added these numbers together, and I got 15,747. And so, female and 19 and under. So here's the people 19 and under. There's the number of them that are female. And so I'm going to do 4,517 over my total. And I'm just doing that in my phone. And I get 0.2868. Does it tell you how many decimal places to use? So the answers come out to 3 decimal places. So again, to 3 decimal places. We look for our third spot, and the 8 bumps this up. So 0.287 is our answer. Age 21 or female. So here, it's an or problem, so we have to subtract the overlap. So age 21, I have 1679 plus 1627, or female, which are these numbers right here, plus, I'll go top to bottom, 4,517 plus 1,553 plus 1627. But we've accounted for, circling here in red. We circled this number twice. So I need to subtract 1627. Or maybe you just like scratch it out. We can just do that. We're going to subtract 1627. So that cancels the last 1627 that I just wrote. And so I add these values, 1679 plus 1627 plus 4517 plus 1553. And I get 9,376 out of my total of 15,747. And I get 0.595. And then finally, the probability that the person is at least 20 years old. And so that's these four numbers right here. There's no overlap. It's just people that are at least 20. And so it's the people that are 20 and the people that are 21. So for this one here, we do 1625 plus 1553 plus 1679 plus 1627. And we divide that sum by the total of 15,747. So no overlap here. You just add these, divide by 15,747. And I will make you watch me put that in the calculator. That comes out to 0.412 for people that are at least 20 years old. Let's look at number 12. If one card is drawn from a deck, find the probability of getting these results. So this homework ends with a bunch of card questions. It's 12 and 13, but I think problem 13 is 8 parts maybe. An ace and a club. This is kind of a weird way for Alex to phrase this, but this just means the ace of clubs. The card I have on top. So this card is both an ace and a club. It is the only card in the deck that is an ace and a club. So that's 1 out of 52. The probability that we draw a red queen, so we're only drawing one card here. A red queen, there's two of them. There's the Queen of Hearts and the Queen of Diamonds. So 2 out of 52 reduces to 1 out of 26. And then a king or a 4. There can be overlap when it's an or problem, but in this case, there is no overlap. Because these are like value cards. The overlap is when you have a value card and a suit. So here, there are 4 kings out of 52 cards. Or a 4, so that's another 4 cards out of 52. And so we do 8 out of 52. And that reduces to math, enter. And we get 2/13. So let's look at 13. Several parts A through H. Excuse me one second. Here we go. So the 9 of clubs, that's easy enough. That's what we talked about. A single card, that's just 1 out of 52. The odds of drawing a black card, it would be the same as the odds of drawing a red card. It's half the deck. Remember that half the deck is black, and then this half is red. So it's 1/2. It starts as 26 out of 52, but it's 1/2. The odds of drawing a queen, again, there are 4 of each value card or face card. So that's 4 out of 52, which reduces to 1 out of 13. A black 10, there's 2 of them, the 10 of clubs and the 10 of spades. And so 2 out of 52 becomes 1 out of 26. I'll do this one over here. So a red card or a 3. Here you will have overlap, because there's a 3 of hearts and a 3 of diamonds. And so a red card, that's 1/2. We add when it's an or. And so, or a 3, there are 4 of those out of 52. You could reduce that to 1/13 if you want. But we need to subtract the overlap, which is the 2 red 3s. So we get, however you want to put this in the calculator, really. I like to think about it as 1/2 is like 26 out of 52. And now if my denominators are the same, I can just, do it in my head. So 26 plus 4 is 30, minus 2 is 28. And 28 out of 52 reduces to 7/13. So again, you add and then subtract the overlap when it's an or problem. The probability that it's a club and a 9, again, it's just asking for the specific, and it's the same card as part A, the 9 of clubs. And there's only 1 of those, so 1 out of 52. A 2 or an ace, there is no overlap here because they're both value cards. So there are 4 2s and there are 4 aces. So 4 out of 52 plus 4 out of 52 is 8 out of 52. And that reduces to what? So I'll put it in the calculator. 8 out of 52 is 2/13. And finally, for this homework and this series of videos, the probability that it is a club, a diamond, or a spade. So it's going to give you 3 of the suits. Again, there are 4 suits, and here we have 3 suits. So it's just 3/4. I mean, you could do 13 plus 13 plus 13, get that sum and divide by 52, and hit math, enter, enter. But we can also just kind of think about it. There are 4 suits. It asks for the odds of drawing anything that's not a heart. And so that's 3 out of 4. So if you have any questions about any of these problems, please reach out, and I'll see you next time.